exercise, we've learned about steel design and beam flexure. We'll break down important concepts like load calculations, bending stress, and design methods, and share how these apply in real-life structural projects. Let's get started!
You know that steel design isn't just about strength. It's also about choosing the right cross-section to handle load efficiently without wasting material.
When designing steel beams, it's not just about using the strongest material. It's about selecting the right cross-sectional shape to support loads efficiently. Shapes like the W10x60 provide both strength and material efficiency. Engineers must consider the balance between safety, strength, and cost.
So basically, we can't pick the strongest beam.
No, we have to find a shape that handles the load but uses the least steel.
Like the W10x60, for this beam, it's too strong but efficient.
Choosing the right cross-section helps the beam resist bending, which is critical to ensuring the overall stability of a structure. For example, wide flanges help distribute the load more evenly across the beam.
Did you know that structures face different loads? Dead loads, live loads, wind, and even earthquakes? Each one affects the design.
Every structure faces a variety of forces. Dead loads refer to the constant weight of the building itself, while live loads fluctuate with people, furniture, and equipment. External forces like wind and earthquakes must also be factored in to ensure a safe design.
We've got the dead load, which is the building's own weight.
And live load includes people and furniture.
Don't forget the wind load as well. Tall buildings especially need to account.
Accurately calculating these loads is essential in structural design. For instance, wind loads exert lateral forces on tall buildings, while seismic loads create dynamic stresses that can shift or sway the structure.
Did you know that a beam bends through stages? It starts in the elastic range, but once it reaches the plastic moment, it bends permanently.
As a beam is loaded, it first deforms elastically, meaning it can return to its original shape when the load is removed. However, once it reaches the plastic moment, permanent deformation occurs. The entire cross-section yields, forming a plastic hinge, an indication that the beam has reached its limit.
So basically, it's fine until it reaches the plastic moment. Then it can't go back.
Exactly, and that's when the entire section yields and forms a plastic hinge.
These stages, elastic, yield, and plastic, determine how much load a beam can handle before it deforms permanently. Engineers calculate these stresses to prevent structural failure, ensuring that beams remain within their safe working range.
Did you know that allowable stress design focuses on the elastic range, but plastic design looks at when a beam might fail under extreme loads?
Allowable stress design ensures that structures remain within the elastic range under normal loads, making it a conservative approach. Plastic design, on the other hand, explores the beam's failure's limits, allowing for better optimization under extreme conditions, ensuring safety even when maximum loads are applied.
So ASD keeps things safe under normal loads, while plastic design shows us how much extra load a beam can take.
Exactly, it helps us design for both safety and worst-case scenarios.
ASD is commonly used for everyday structural design, while plastic design is vital when considering maximum load scenarios, like in bridges or earthquake-prone areas. The choice of design method depends on the project's safety requirements and environmental factors.
Create build-up beams by combining plates and sections. This allows for custom design to handle specific loads.
Built-up beams are created by combining different steel sections, allowing for tailored solutions in cases where standard beams might not be sufficient. This design flexibility is crucial in complex structures where load distribution needs special attention.
So we can just build our own beam from different parts?
Yep, and we need to tailor it to exactly what the structure needs.
Understanding these concepts allows engineers to design safer, more efficient structures that stand up to various forces. With the right calculations and design choices, steel beams provide the backbone for modern architecture and
Thanks for
infrastructure.
watching. We hope you enjoyed learning about steel design and how beams handle loads. If you have any questions or want to know more, feel free to ask us. We'd love to discuss this further.